Okay, so similar to previous years that I've done, chapter 20 is going to be the very first one that I will use to revise unit 3 and 4. Okay, and similar to previous techniques, our previous revision like lessons, I will, the easier ones, I'll just get you guys to get started straight away. And by the time I finish it, you guys should have either finished it or get ready to move on. Okay, so the idea is that I will provide as much so as many solutions as I can for most of these questions here. Okay, so the complex familiar is the one that I want to focus a lot more on, but I will provide solutions for everything. So the structure of chapter 20 is, this is a revision for both units 3 and 4. So know that you guys haven't actually done the all of the questions for unit 4 chapter 19 yet. All right, the extended response ones are really difficult. We'll have to practice those ones when it comes closer to the external exam. But 20A, technology free again, similarly. Now 20B, this one here, the multiple choice, this time you guys have to do the multiple choice questions. Okay, by hook or by crook, if you guys can't do it at home, I'll just have to get you guys to do it here. All right, we'll see. But you guys need to try out these multiple choice. Oh, was there multiple choice in the exam on unit 4? Okay, external only. All right, so that's multiple choice, and then the next section would be extended response. So these questions are the kind of question that would give you some opportunities to practice problem solving for complex unfamiliar. So these questions, right? These complex unfamiliar questions is about problem solving. Okay, because I'm assuming you guys understand most of the concepts already, so you need to practice problem solving. The only way to practice problem solving is to problem solve. There's no way for me to teach that to you guys. Okay, you just have to look at the question, look at it, and then stare at it, and then think about ways to do it. And you may not be able to do it straight away. That's okay. Put it aside. Come back to it later. When you come back to it again, you still have absolutely no idea how to do it. Reach out for me to help. Okay, but you guys have to practice problem solving, which means you need to get a problem that you can't solve and you try to solve it. Okay, and then if you can't solve it, reach out to me. You can't just be like, I give up. Okay, because then you will not be able to do the complex familiar and complex unfamiliar in the external. Because in the external, when it's complex, it's complex. All right, and you actually need to practice a lot of the skills, and then be comfortable seeing something that's completely new and actually be excited about it, because these questions are quite interesting. It's different from just derive the following equations twice, find the second derivative, right? These ones are actually some things that when you do it, it's a little bit different. It works you up more from when you are doing all these questions. Okay, if you get to the point where you're comfortable with most of the main concepts. So that's why these questions are quite important. Now, to actually let you practice problem solving, these extended response questions, right? I don't think I will provide you guys with a solution straight away. Okay? Because if I give you guys a solution straight away, you won't be able to have that chance to practice problem solving. So depending on how much time we have when we get to this chapter, I might get you guys to try to solve it together first, giving you guys some time. And then I will provide you guys with a solution or with some hints to go through it. Okay, it seems like everyone has a little needs a lot more practice on problem solving. Okay, all right. So that's the structure. 20C and 20D. Well, note that 20C is all of these problem solving ones. 16, 17. Let's see, 20 something questions here. Even 30 actually. 30. Wow, that's a lot of questions. All right. So extended response. These are really long ones. Are here. Okay, so that's 40 questions. 40 questions, 40 opportunities for you to practice solving things that you most likely haven't seen before. Okay, and think about it, to think of 40 different scenarios. All right, 40 different questions that students have not seen before is really difficult. Okay, and the more of these questions you do, the higher the chance that you will go to, when you see something in the external, it's it's kind of familiar. All right, because yes, math, you can design the question however you want, but you guys are in high school. It can't get that hard. Right? The curriculum is fixed. It can't get that much harder. If you're comfortable with the main lines, it's how you guys are telling me that there was that question where you optimize the speed running, right? We've done something like that before. That's why when you see it, it's easy, right? We've done that before. But imagine if that's the first time you saw something that has the speed and then the velocity, you wouldn't even think about adding the 2 time taken. You won't be able to think of that straight away. Does that make sense? So in order to ace the external, you have to do a lot of these really difficult questions to see all kinds of like ways they phrase the questions differently. Okay, if I give you guys the answer straight away, I'm robbing you guys of the chance to practice that. Okay, so we have to see how you guys go, but there are 40 questions. Even if we do 10 questions a week, which is really, really hard to go through 10 of these questions per week, it still take like 4 weeks to go through everything. Okay, so I have to see how fast you guys go. Now these ones, the last chapter 20D, you guys gotta do this yourself. Okay, so I aim for you guys to try out these questions yourself, because it's just start from simple familiar to complex familiar and then complex unfamiliar at the end. Alright, okay, so let's get started. For today, we're starting with the first one, technology free question. So we'll just go question by question. I'll get everyone to tell me what's the level of confidence they have for a question like this, and then if everyone's confident, then just get started. Okay, I'll get started on my explanations here as well, but I won't actually say anything. So only look if you need help. If you can do this correctly and finish it before me, so be it. All right, and then you can just chillax until we get to the next question. Okay, have a look. What's the main idea behind this question?
Unit circle.
Unit circle, very good. All right. What about the unit circle?
The symmetry property.
Yep, the symmetry properties. Now, two special question here. All right. This one, what does it? What does this one link to? It's not the symmetry of the unit circle. It's something else. It's something else. What's pi over 2?
90 degrees.
90 degrees. So what does that remind you of? $90 degrees plus an angle or 90 degrees minus an angle?
90 degrees minus.
Yeah, you have both plus and minus, right? You have the plus, the minus version here, and then the plus version here. What does it remind you of? Have you guys learned circle mensuration?
Like the arcs, stuff like that.
Not quite. Okay, this one might be a little bit new for you guys. All right, let's see. These two questions is based on the idea that when you have the unit circle, right, it's not the standard one. So let's say if you have this one here, if this is the angle theta, right, 90 minus theta is this one over here. Okay, so this is pi over 2 minus theta, right? And then note that this angle here, so sine of this angle is actually the cos value of the original angle, because these two sides, because these two sides are the same. Well, okay, another way to think about this is if you have a right angle triangle. If you have a right angle triangle, and again, this is it's not a new concept, but it's something that I have sort of avoided teaching until now. Now that you guys are okay with the other concepts, and I'm going back to this one. So let's say this is alpha theta, right? And this would be pi over 2 minus theta, right? It's just the other angle in the triangle, right? So let's say this is B1 and this is A, for example. You see, sine of theta would just be B over 1, which is B, right? But cos of pi over 2 minus the angle is what? What's this?
Also B over 1.
It is also B over 1. Does it make sense, Emily? Because this angle is here and adjacent to that is B. Right? Ka. Right? So katoa. So, but opposite of theta is B. But adjacent to pi over 2 minus theta is actually also B. You see? So sine of theta is the same as cos of the complementary angle. Yeah? Does it make sense? Does it make sense? Right? So if you get a complementary angle, aka this version here, right, that would be the easiest way to work this one out. But how do we deal with pi over 2 plus x? How do we do pi over 2 plus x? And cos of that?
Would it
Yes, Suleiman?
be the same thing, but like a negative was value?
Yes, very good. Okay, so cos of that, let's say pi over 2 plus x is going to be this one here, right? Pi over 2 and then plus the angle theta, right? It will be that one there. And note that cos of this angle, because it's in a unit circle, right? It will also have, cos of this would be the length of that side there. Okay, over the hypotenuse, which is always 1 in a unit circle. Right, does it make sense? Yeah? No? Actually, pi over 2, the cos value is actually related to, so the cos value is, again, this angle pi over 2 plus theta would actually be this whole thing here. Right? It's not pi minus theta, but it's pi over 2 plus theta. So the symmetry says that the cos value of this one is the same as sine of theta, but the negative version. So this is the same as negative sine of x. Can you see it? Maybe, maybe no. Okay, and use an actual example. Let's say theta is equals to 30 degrees, right? Okay, what's cos of 30 degrees? Let's say what's sine of 30 degrees?
1 over 2.
Yeah, 1 over 2, right? Let's say sine of 30 degrees is 1/2. Now let's draw a unit circle here. And then we'll draw out 30 degrees is like here, right? So sine of that is 1/2, which technically would be like here. Okay? 30 degrees and sine of that is 1/2, right? This is standard stuff, yeah? Now what's 90 plus 30 degrees? So when you have pi over 2 plus theta, which is 90 plus 30 degrees is 120, right? But in order to represent 120, I will draw it as 90 degree and then I plus 30 degrees, right? So that's 90 degree and then plus 30 degree. It will be this angle here, right? Does it make sense? So now it's represented by that point there. Okay, so note that when I do pi minus theta, minus alpha, which is 180 minus 30 degree, then it is 150 degrees, right? And 150 degrees is where? Well, 150 degrees is the symmetry angle. The symmetry angle is the angle that when you draw it, you make a box, right? You kind of make a box like that, okay? So that's why this is a symmetry angle here. But note this symmetry angle. What is the difference between this triangle and then the blue triangle here? Right? Remember, this is 30 degrees and then this also is 30 degrees. What happens with the what do you guys see is the difference between the blue triangle and then the gray triangle?
Blue is for the sine axis and the blue is of course.
Yes, that's right. The blue is on the sine axis and the angle is the one in between. You know, the angle is this one here, right? Okay, so sine of this, and note that these two triangles are the same. Okay, this triangle here, right, and that triangle here, they are congruent triangles. They're congruent triangles. Okay, which means that the side on the top here is the same as the side over here. Does it make sense? Yeah. And because of that, okay, what's sine? What is sine of 150 degrees? The gray one here. What is sine 150 degrees?
Is it just half?
It is just a half, yes. Remember symmetry angles, right? Symmetry angles, so they both must have the same sine value, which is a half, right? Okay, so then sine of that is, note that sine of 30 degrees is the length of this side here over the hypotenuse, right? So what do you think is, let's say, cos of 120 degrees? Yeah, anyone? It's cos of 120.
minus 1 over 2.
It is minus 1 over 2. Why, Suleiman?
You do cos of 180 minus.
Oh, you're doing 180 minus 60. No, this idea is a little bit different. This idea is the idea that the cos value, okay, all right. This angle here is 120 degrees, right? The cos value of that is basically what's this distance here, right? And that distance is the same as this distance. That makes sense? Because when you're looking at the cos value, you're looking at the value on the cos axis. And the coordinate, whatever this is, 0 point something. In fact, this is actually negative 1 over 2, which is negative 0.5. So the distance here is the same as the distance here, right? Because it's, we're just making a rectangle, right? And then what did I say before? The distance on top is the same as this one here because the two triangles are congruent. So cos of 120 degrees or cos of, right, or cos of pi over 2 plus the base angle 30 degree, right, or 90 degree plus 30 degree is the same as, instead of cos, it will be sine, but then it's in the negative region. So negative sine of 90 degree of the base angle 30 degrees. That make sense? Kind of? Okay, all right. If it doesn't make sense, how about this? I'll tell you guys the formula. Okay, so complementary related angle. So complementary angles. Okay, sine of pi over 2 minus a certain angle alpha will always be the same as cos of the base angle alpha. Okay, so if the two angles are linked by, instead of pi, it's pi on 2, sine becomes cos. Sine of one becomes cos of another. And similarly, cos of this would become sine of the base angle. It's the same as sine of the base angle alpha. Okay, remember these two ideas are based on the triangle thing that I said earlier, where let's say this is the angle alpha, right? And then sine of alpha is a over 1, and then cos of the complementary angle is also a over 1, right? And then cos of alpha is b over 1, and then sine of the complementary angle is also b over 1. Does that make sense? Yeah? So this is the easier one to see, where when you have just pi on 2. Instead of pi, it's pi on 2 minus an angle. Alright? But what if you have something like sine of pi over 2 plus an angle? Now the easiest way is see that the main angle that is there related to is pi on 2. Whenever you see pi on 2, think complementary. If it's when you're thinking complementary, sine will be equals to cos of the base angle. Okay? But then you got to remember sine of this, right? You got to remember sine of this angle is in what quadrant? It's in the second quadrant, right? Okay, and the second quadrant is positive, so that would be the same as cos, positive cos. Okay, but then if you have cos of pi over 2 plus alpha, now again, when you see the angle that they're related to is pi over 2, which is 90 degrees. So think complementary angles. Cos will be equal to sine of the base angle. But would it be positive or negative? Now let's see. Pi over 2 plus alpha is this one here. And then, so pi over 2 plus alpha will be like somewhere there, right? And the cos value in the second quadrant is negative. Okay? And that's why cos of this angle would be negative sine of alpha. Negative sine of the base angle. Does that make sense? Yeah? So just remember, the key part here to remember is whenever you have sine and cos of an angle that is related to the angle 90 degrees, you got to think complementary. So sine of an angle will be cos of the base angle, right? And cos of that angle is sine of the base angle. And then you just got to locate where that angle is. in the unit circle in order to find out whether the final answer is negative, which is like this one here, or just positive. Okay, so complementary, sine becomes cos, right? And then check what quadrant. Okay, right? So yes, now you guys need to try out this question here. Get a piece of paper, work on it. All right, and I'll slowly write the answer here. You can ask me any question before we move on.
Is the first question is negative 0.3?
Sine negative x is, yes, that's right. Alright, that's all of the answers for question 1. I'll spend a bit more time on this complementary angle thing. Okay, let's say sine of 30 degrees. Okay, sine of 30. Okay, let's say sine of 20 degrees is. I'm going to use actual values here. Alright, sine of 30 degrees is 0.34. Cos of what angle is also equals to 0.34? Suleiman.
Cos of
The complementary angle, which is
5
or 90 degree minus that, which is 70 degrees. If you punch in cos 70 degrees, the answer is exactly the same. Alright, you see a little bit of a pattern here. Okay, so let's say cos of the angle 15 degrees. Okay, so cos of 15 degrees is going to be, cos 15 is 0.97. Okay, Emily, sine of what angle? Sine of what angle is also 0.97? The complementary angle is the answer. What's the complementary angle of 15 degrees?
75.
75 degrees, yes. If you punch in sine of 75 degrees, you will get 0.97.
Oh, okay.
Does that make sense?
Yeah.
Now, more advanced version, let's say cos of 20 degrees, okay? Let's say cos of 20 degrees is 0.94. Sine of what angle will be negative 0 cos 0.94. Oh, this one might be a bit hard. No, actually I'll go with this one. Sine of 20 degree is 0.34. Cos of what angle would be negative 0.34. Remember, it will be linked to the complementary angle, right? But for cos to be negative, what quadrant must it be in? Second quadrant. So the angle must be 90 degree plus or minus? Plus, which is 110 degrees. Right? Does it make sense? If you punch in cos of 110 degrees, the answer is negative 0.34. It's exactly the same. Okay, now let's see if you guys can actually do this one here. Sine of, let's say cos of 20 degrees would be 0.94, right? This hard one that I skipped for you guys. Now, sine of what angle would be negative 0.94? You can use your calculator. Punch it in. Make guesses. You can't use inverse sine, right? You have to guess what angle it is. So you can only type in sine of, let's say, if you would try type sine of 110, right? See what it is. Okay, we see if it's the answer we're looking for, negative 0.94 to 2 decimal places, or 0.9.
0.94, yeah.
Yeah, but it's not negative. What angle would give you negative? Alright. Which angle would give you negative? Because if you just simply punch in sine of 90 degrees plus 20 degrees, which is 110, it would just be positive 0.94. So how do you get negative 0.94? Give me an angle that is between 0 and 360 degrees. Which one? Which angle?
Pi on 2.
No, sine pi on 2 is 0. It's just 1. Okay, I'll give you guys a hint. This question, you guys might need a bit of a hint. So based on this one here, sine 110 is 0.94, right? Yeah? So this one means that in the unit circle, if you draw the angle 110, which is that one there, sine of that, right? Sine of that is 0.94. What angle would have, and this is angle 110 degrees, what angle would have the sine value negative 0.94?
Is it
250?
Yes, 250 degrees. Because if you want the same sine value, remember this is the sine axis. If you want the same sine value but negative, it's down here, right? This is negative 0.94, right? And then you find which point on the unit circle. One of them is this one here, which is essentially, so the base angle here is technically is 110. So the other one's also 110 on this side, which means this one would be 360 minus 110 degrees, which is 250 degrees. So one of the answers is going to be 250 degrees. What's another answer? What's another answer? What's another angle? Would have sine also equals negative 0.94?
290.
How'd you get 290?
The reflection of 251, like.
Yes, correct. It is a refraction of this one on this side here, right? So this angle, if you were to calculate that, remember 110 means this is 70. Means that one is also 70. So this angle would be 360 degrees minus 70 degrees, which is 290 degrees. All right. So this is when you calculate sine of 290 degrees, it's also negative 0.94. Does it make sense? Yeah. So these are how the questions in the unit circle. You can just apply the idea of the unit circle to solve these questions here. All right, a little bit tricky. All right. So first question is already a bit tricky, but the second one is a bit easier. All right. So second one you should feel that it's quite familiar, hopefully. All right. What's the idea for question 2A? Anyone?
It's kind of like optimization, like finding one thing in terms of the other.
Not quite. Not quite. It's not optimization. Something else. The keyword is something else. The hint is this is the main concept of Unit 3.
Derivatives.
Sorry?
Derivatives.
No. They give you what? They ask you, so what's the technique here? Not deriving.
Antiderivative.
Antiderivative, yes. But why do you need this?
For the plus C.
For the plus C. Does it make sense, Emily? Yeah. So what's the rule? So the first one is just trigonometry. This one is E. I'll see how you guys go with that. What's the rule for the last one here? When you antiderive something that looks like that, it will be?
Change to a negative.
No.
ln.
ln, yes. Remember, this is 1 over, and this one would just be 2x minus 3 to the power negative 1. But when you add 1 to this, you get 0. When you antiderive, you can't divide by 0. So when you see power negative 1, you gotta think ln. Okay? Because when you have the original function, which is going to be ln x, then the derivative f dash would be 1 over x. Right? But if the original function is ln of a linear function, what do you have to do?
To divide with the coefficient of x.
Yes, yes. So if this is 1 over ax plus b, then the original, when you antiderive, would be ln of ax plus b, and then you divide by the coefficient of x, which is a. Okay, so that goes from right to left here. All right, try this question too. Go. All right, I'll slowly start working through each of these questions here. So question A is when I'm going to write out everything fully. If you need any hints or any refresher, look at question A, and B and C, I will do it a bit more, I'll shortcut through it a little bit. That's all the answer for question 2. So for whoever has finished up question up to 2C, just try question 3 here. Okay, no hint for question 3, you just gotta be able to do it. Alright, question 3 is really short. If I have to write out the answer, it's really, really short.
Is it just an equation?
Yeah, just an equation. Alright, and I think the question might require you guys to simplify that. Okay, so simplifying this one using the formula.
Wait, no, like the null factor.
Sorry?
The null factor.
No, there's an expression. So you're finding this, which is an expression. It's not an equation. You can't solve anything.
It's
Right.
Yeah, okay.
This is the final answer. Okay, not bad. All right. The next 2 questions should be simple familiar. I think the first 2 questions is just like really deep knowledge of unit 2. That's why they think it's simple, but most students don't even know about it. These ones should feel quite simple. Now, we got question 3, Emily?
Yeah.
Okay, move on to question 4. Again, this one, no explanation for me. It's just standard. Any question for B? Sulaiman?
No, I was looking at A.
Oh, okay.
I figured it out.
A is just a chain rule, yeah? B is the product rule. Any question, Emily?
What did I get 21?
21? I took out 3 from these 2.
Oh.
Alright, that's the answer for question 4, A and B. Next is question 5, and I'll start working through this as well. Right, here's the full answer for 5A and B.